That's weird. Sorry, that's weird. Okay, I'm looking for my zoom, my automatic zoom. All right, let's try this. Oh, hey, it did it. That's better. Now you're solving. There's 4 operations that you use to solve, and you guys know what those are. It's sort of reverse thinking for simplifying. Simplifying is PEMDAS. You got to do that every time when you simplify. Parentheses first, and then you got exponents, multiply, divide, and lowly subtraction is the last thing, lowly subtraction. In solving, I highly recommend, I don't know, if I were gonna do anything first, you'd end up taking care of the parentheses, so use the distributive property. So if I see, let's see if I can show you anything that shows distribute. Okay, look it over here. See, there's a distribute. My hands look weird.
It happened when you changed you kept changing all the, yeah, that's
better, okay. Monochrome. Okay, so distribute first, that's what I would do. See, in solving, this is for solving right here. Distribute first. Second thing I do is add, subtract. Add, subtract. So you're going to move things around the equal sign. So you got an equal sign. Think of it as a balancing beam. I don't know, maybe your elementary school teacher might have said like a teeter-totter. It's balanced right now. So see that 4? I want to move it over there. Okay, why? Because the goal, get your variable by itself. And I'm highly, highly, highly recommending, and there's a big reason when we get to 2.8 or 2.9, I'm highly, highly, highly recommending get the variable by itself, left side, left-hand side, left-hand side. That's what I would do. So my goal is to keep X on the left-hand side. It's already there. I want to move the 4. Now there's no parentheses right here. And so that means there's no distributing. So then I'm going to add, subtract. What you do to one side, do the other. So I think most of you probably say, look at, the answer is 1. Isn't it? 1 plus 4 is 5. The answer is 1. Right? Subtract 4, subtract 4. Okay. This is like a stacked method. Author might give it a different title, but I might call it a stack method. The other way you can show your work would be, here's the original. And if you want to go X plus 4 subtract 4 equals 5 subtract 4, what you do to one side, do the other. I don't care which way you do it. But I want you to show me some work. Now that's on the homework. Just don't give me answers on your homework when you submit it to me, because that's all I'm doing. All I'm looking at is thinking you've got an answer book and you're just giving me answers to get your 20 points. You don't know what you're doing. So show me process, even though I'm not grading your homework per se for process or correct answer. Show me process, because if it's only answers, I'll kick it back at you and say, got to have a lot more than that. Otherwise, it's your throwaway. And then the group quiz. I am looking for a bunch of process on the group quiz. Now on the exam, I'm just looking for the answer. So here I go cancel. This would be X equals 1, and you box your answer. Or on your homework, I don't care whether you box it or not. Same with the group quiz. I don't care if you box it or not. How do I know X is 1? Well, this is too easy. 1 plus 4 is 5. You see how I'm checking it? And you always check your answer. Always check, always check your answer in the original equation. So you always go back to the original. That was the original, Jeff, I know. Look at this one. I'm going to have probably 2 steps on this one here to get to the answer, probably 2. I can't come up with the right answer in my head. That's impossible for me. It's too much work. So I'm going to do a process to get it down to where it's x equals something. And then when I get x equals something, I'm going back to the original here and check it. And the reason why you don't want to do it at any other step, it may be your answer worked at a step or 2 from the answer, but it doesn't work in the original because you made a mistake somewhere. And you wouldn't know it until you check the original. And it's likely that checking is harder and easier to make a mistake than actually solving. The checking can be much more work and easier to make a mistake. So just keep that in mind. All right, let's see, distribute. Probably before add and subtract, I might do, oh, I don't know, 1B or something like that. 1B, collect like terms. Now, after you distribute, you're collecting like terms before you move anything around. Adding, subtracting is moving, and then at the end, I would do 3, multiply, divide, multiply, divide. So you're like here, I'm going to collect like terms. I'm not going to move the 7 over here. I'm not going to do that. I'm going to collect like terms and then see what I've got. So collect like terms. Okay, that's 2x. And then 7 subtract 3. Now, in my brain, I can jump over. You guys know that too. I can jump over and go x plus 2x. I don't have to show this and say, Jeff, that's called the commutative property that allows me to do that. I don't need for you to do that. I know your brain's doing that automatically. In your head, in my head, I went x plus 2x is 2x. But to go from here to there, that's called the commutative property for addition. So I don't need that to be written down. Just simply go 7 subtract 3 is 4. And then now I'm done with the collecting like terms, and there was no distributing. So now what I'm going to do is I'm going to move things. And I'm going to keep the x on the left-hand side. That's the goal. So let's talk about the x. Here they are. They're on opposite sides of the wall. I want to move that one over this way because I want ultimately all the x's to be on the left-hand side. So I'm going to take this x and subtract it like this. And I'm going to end up having 1x, but I don't have to write the 1. And then plus 4 is equal to, well, that's gone. Subtract 2. And then looks like a pretty easy idea for you guys. Subtract 4, subtract 4. And then ultimately you get x equals -6. So it looks like about a 2-step process, maybe 3. Now to see if this really works, here's your check. You know, you're going to check it in the original. So I'm taking this right here and putting it in everywhere I see an X. So I'm going to put parentheses because the negative is going to get mixed up, especially maybe in here. It's going to get mixed up. So I'm going to go parentheses -6 plus now what I'm going to do is just combine the numbers on the left-hand side and then combine the 2 numbers on the right-hand side and see if they're identically the same. If they don't match up, then one of 2 things happen. If they don't match up, then one of 2 things. You made a mistake in your plugging in your check and checking. You made a mistake somewhere. That's a possibility. Or -6 really isn't the right answer because it didn't check. What I'm hoping for is it's identically the same. All right, so this side here is easy. That's -8. Okay, over here. Okay, that's +1. And that's -9. And sure enough, -8 equals -8. Check. That means this is the answer. That means that's the answer. So 2.2, 3, and 4. I'm combining all of it today because it's all about solving. What I just did was probably 2.2. 2.2, all 2.2 was using the properties of combining like terms and then just adding and subtracting. I didn't multiply anything or divide anything. Whereas number 3, you see number 3 right here? How do I get rid of the 2? I'm gonna have to divide it out because ultimately I just want x or a 1x. So this is probably a 2.3 problem. And this one's a 2.3 problem. And so is the one below it. So I've just given you 2 problems that would be enough, in my opinion, my humble opinion, along with the author's examples, that get you to doing 2.2. Okay, now 2.3. So I would say the next 3 are 2.3s. How do I get rid of the 2? I think all of you know. Well, by the way, the answer's got to be 4. The answer is 2 times 4 is 8. The answer's got to be 4. So divide by 2, and sure enough, we all know that was supposed to be 4. No checking on that one. Now this one here, it's 2/3 times. Now you got a couple options on doing this one. You could, one at a time, I see the 2 and the 3, one at a time, make each number go away, one at a time. For instance, if I want to make the 3 go away, I would multiply both sides by 3. If I want to make the 3 in the denominator gone, you would times by 3, times by 3. And then your next step would be to make the 2 go away. So you divide by 2, divide by 2. That's like a 2-step process. Here's the other way you could consider it in 1 step. I'm going to use this word that you guys saw in 1.8, reciprocal. So the reciprocal of 2/3 is actually 3/2. So if I went reciprocal to both sides of like 3/2 times, this takes care of the number. This will make this into a 1, which is, I think I called it the identity element for multiplication, the number 1. Anyway, that's 1, or gone, and you're left with x. And then over here, you have to mess around with your multiplication of fractions. Okay, how many operations do we have? 4. Well, base operations, add, subtract, multiply, divide. When it's dealing with fractions, all right, I'll give you an example here. Okay, I'll rank these. Meaning what's the easiest one? Out of these 4, what's the easiest one? And I hope all of you are going to say, I think most of you are going to say, number 1, that's the easiest one. And the reason for that is you just multiply straight across. This is 1/6. That's easy, easy, easy. Okay, now you're down to 3 left. Well, what's the next easy? I personally think this is the next easiest, so I'll rank it as number 2, because all you have to do with dividing fractions is just take the reciprocal of one of those fractions. And by the way, it's always the second one. All you have to do is take the reciprocal of the second fraction, change the division to multiplication, and now it's back to the easy one. So multiplying, dividing fractions, always easy, always easy. These are harder. and scares some of you because it's been a while. You need a common denominator and blah, blah, blah. You know, so Jan can help you with that when you have to deal with it. Or if I've got some examples, I'll remind you how to do it today. You know, between these two, which one is the next one? I don't know, maybe adding, just because adding sounds better than subtracting. So maybe this one is my next one, but they're both like tied for harder. I guess that's how I would rank them. Easiest, next, and that's the hardest, I guess. So over here, I can multiply straight across. But Jeff, there isn't anything down here. Yes, there is. It's a 1. Oh, yeah, I can go straight across. That's negative 12 over 2. Negative 12. This is negative 12 over 2. But Jeff, I think I remember cross-canceling in my arithmetic class. Yes. Yeah, you can do that. I mean, 2 goes into 4 twice. Get the same answer. Your choice. I don't care which way you do it. Negative 6, it's still negative 6 no matter what. It's your choice. All right, this one. I want to get rid of the negative and the 5. So how about multiplying by negative 5 both sides? Because that would make that go away, and then you got x equals negative 30. And again, if they ask you to check it, you always go back to the original. Okay, now, if I were categorizing this, this is right here. This is probably 2.3. This is 2.2. 2.2 is adding and subtracting for the most part. 2.3 is multiplying, dividing. And then 2.4 is the hard ones. Hard meaning there's a lot of steps, multiple steps. And there's a couple little quirky answers that we're going to find out too. A couple little quirky answers. So the next page should have some of those. Yeah, next 2 pages have bigger problems to consider. Oh, haha. Hey, Jan, look at this.
Oh.
Same thing. And I called it that. And then I say more examples. That's weird. All right, I just did these. You don't need to redo those. Oh my God. See, that's why my packet's always a draft. Work in progress for the past 10 years. Yep, okay, that was weird. Okay, flip the page. If you've got your packet, flip the page. And now we're just gonna go step through 10 problems, it looks like, maybe 10 problems. All right, next one is one of the scary ones for some of you because you see, oh my gosh, I've got fractions. So what I'm going to do is I'm going to get the x's on the left-hand side. So I'm going to subtract 3/2 x. I'm going to do it in little steps. Some people have asked me, Jeff, could I, in the same step, add 1 to both sides? And if you feel like you know what you're doing without making a careless mistake, I'd say, yeah, that'll work. But maybe less is better rather than more is better. Less being more, well, maybe more is better. More steps are better. So I'm going to do it in pieces. Oh, hey, adding and subtracting. Common denominator is already there, which is a very nice thing. And then you go 5 subtract 3 all over the 2. So 5 subtract 3 is 2. Oh, geez, that's convenient. Now, some of your homework problems, not all of them, but some will say, check your answers. Some of your homework problems will say check, not all of them. Let's see, 2.2. Okay, here's 2.2. See, it says solve and check. Solve and check. Got to show the check. Down here. Solve and check. All right. That means you got to, oh man, see, look at, that's going to be challenging, especially, well, there's one that's kind of like the one I'm just doing right here to check that. And they get bigger and it's harder to check. It gets messier. But if you see the next one, it says mixed practice, just solve. It's up to you if you want to check it. You got the time. Okay, 2.3, probably similar instructions. 2.3. Oh, okay, this one just says solve, but earlier ones, solve and check. Solve and check. 2.4. Just solve. They get harder and bigger. So 2.2, 2.3, just do some checking. And yeah, so I'm going to check this one. I'm going to check this one. You're going to check the original. I'm going to put in the -3 right here. So 5 halves, parentheses, -3, and so on. Don't forget, you got a 1 underneath these numbers. All right, -3. Is -3 a real number? Little review. My general question. Thumbs up, I guess, or thumbs down. -3. Okay, thanks, Russ. Is -3 a rational number? Thanks, Russ. -3 an irrational number? Russ is the spokesperson for the class. I can see Russ on my screen. Thumb up or thumb down, Russ? Irrational. Thank you. Okay, is -3, Russ, an integer? Is -3 a whole number? How about a natural number, Russ? Good for you. A plus. A plus. Now, multiplying straight across. There's no reducing or canceling. Multiplying straight across, you get -15 all over 2. Subtract 1 equals, multiply straight across, -9 over 2, subtract 4. All right, now it gets a little tricky. Now, Russ, let's see. Again, I'm going to go on Russ because I see Russ. Is this a mixed number, Russ? Thumbs up or thumbs down? This is a mixed number. Thumbs up, thumbs down. Mixed number. Yeah, sorry. Now you're down to a A instead of an A plus. This is called an improper fraction, Russ. Improper, because the numerator is bigger than the denominator. A mixed number, mixed, would mean 2 goes into 15 7 times. So you got -7 and 1 left over. That's called a mixed number, a reminder. But don't change these to mixed numbers. I'm highly recommending you keep them as improper. So working the left-hand side, I need a common denominator of 2. So -15 all over 2, subtract 2 over 2. Now I've got -1 is written as a common denominator. And over here, like manner, I'm going to go -9 over 2. And then you're going to go dot, dot, times 2, minus 8 over 2. Now, since there's common denominators, I get to add or subtract the numerators. Negative 15 subtract 2 is negative 17, all over 2. Same thing here, all over 2. Negative 9 subtract 8, negative 17. Touchdown. It worked. Meaning I can really super box this answer because that really is the right answer. I'm pretty convinced now because it checked. Well, what checked? The number 3. Look at how much work had to be done for that just to check it, where it was not too difficult, not as bad over here with solving. All right, enough with the fractions for now. Let's distribute. This looks or feels a little easier. Distribute, distribute. So I get 45, subtract 9x equals negative 3x. Now I've got to keep the x's on the same, on the left side of the equal sign, and the 45 has to go over that side. So I think I'm going to move the 45 first. I'm going to move it over there. Okay, that's gone. Now, these are not like terms. Not like terms. So you got to write it separately. Now, it doesn't matter whether it's negative 45. See, right, it doesn't matter whether it's negative 45 is first and then it's minus 3x, or make that first and that second. It doesn't matter. Okay, the next thing is to move the 3x over this way. So I'm going to add, not 4x, 3x. So if I haven't made a careless mistake, by the way, I will make mistakes. Sometimes on purpose, just to see if you're paying attention, but I will make mistakes accidentally. I'm human. I'm not perfect. I'm old. The brain goes sometimes. And you're going to correct me. I mean, if you think there's a mistake, say, hey, Jeff, can you go back to the step before? I'm okay with you stopping me because I don't want to go through the old problem working out the mistakes. And if you've seen something that doesn't look right, so just ask me, Jeff, go back. I didn't get that. Like here, Jeff, I don't get what you're doing. Gosh, I thought that was negative 48x. No, because that doesn't have an x. So these are not like terms. Can't do that. So write it like this. Add 3x. This is gone. Negative 6. Okay, negative 6x. I think that's right. And then what you're going to do is divide by negative 6. All right, does 6 go into 45? No, it does not. But can it be reduced? Is there a number like the number 2? No, but how about the number 3? Does 3 go into both? Is there a 3 times a number gives me 45 and 3 times 2 is 6? Is there a 3 that goes into both? You could use your calculator if you wanted to. Some of you, this is not an easy one.
Maybe 15 over 2.
It would be, thank you. Yep, and 2 negatives make a positive, so this would be your final answer. I don't need you to turn it into a mixed number. You don't have to. Not wrong, but you don't have to. Now, here is something that's interesting. On the multiple choice test, where I'm not asking for any work, it's just the right answer. Let's say this was given to you, this problem, and you say, gosh, I get it. I know how to do this. I mean, it makes sense. And I get down to there. And you get down to this answer right here, and you look at your choices for your answers, and it's not 15 over 2. The correct answer could be either in mixed form, a version of this. It could be like 7.5, or it could be 7.5. It could be in the decimal version. So just be aware that there's different versions of the answers that are out there, and Hopefully you picked the right one on the test. Okay, this one here, distribute, distribute.
Quick question, Jeff.
Yes, please.
You said you always wanted X on the left side, correct?
I think you'll be safe to do it on the left-hand side. Is it wrong at the end? Let's say, which one was an easy one? I think, oh, like this one here. Is it wrong for it to be like this? No, it's not wrong. It's not wrong. But if you start thinking about, I always want to, sometimes I'll put the X on the right, sometimes it's on the left. Chapter 2, Section 8. That's what it's coming down to. So you really don't know why I'm saying keep it on the left-hand side until Chapter 2, Section 8. That's the big reason. So I'm highly recommending that you just force yourself just to do the X on the left-hand side. Okay, that's minus 0.1x. That's plus 0.2 equals negative 0.16. Now, I had to do that in my head. I should probably check my answers at the calculator. You know, multiplying by decimals in my head or your head might not, you might make a mistake. 0.1 times 2. 0.1 times 2. Okay, I got that one. Well, look at, I made a mistake. No, that one's okay. I didn't make a mistake right there. And over here, 0.02 times 8. Yeah, that's good. And there was a negative sitting out here. Okay, combining like terms, these guys are like right here. So I'll use my calculator again. Instead of doing it in my head, I got 0.06, 0.06, and then subtract. Well, if you want to include the 0, no problem, 0, but put the point and then 1. So that's negative 0.04. Don't forget the x. Okay, now I'll move this one.
Jeff, do you want to explain why you didn't put negative 0.36 divided by negative 0.4? I mean,
O's a letter.
0.
Remember, come on, but, you know.
Come on, I drive on 101.
Which one are you doing?
Well, just when you were putting it in the computer, you didn't put the negative signs, which we know that negative divided by a negative is a positive.
Oh, yeah, that's why I didn't do it, because these two ultimately would be positive. That's why I didn't. So just for the rest of you know, two negatives make a positive, gone. Do you have to put a plus sign in front of that? No. Yeah. I'm looking at time. I don't think I want to do that one. I'm going to work my way backwards for some reason. I don't know. Let's see. I'm trying to think of negative 4x. No, not that one. That's 10. No, not that one. Let's see. One of these. I'm looking to see a particular one. Maybe this one. Yeah, this one. I'm going to do this one. Okay, combine like terms. These guys are like terms, so I got minus 12x, subtract 20, and right here. And let's move the 12x over the other side, and something interesting or weird happens. And it's not a mistake. I have no x left. The x disappears. It's not a mistake. So in 2.4, the rest of these are 2.4. In 2.4, you're going to get some problems that will occur like this. All of a sudden, you go, whoa, I made a mistake. You didn't necessarily make a mistake. When the variable goes away, variable disappears. And statement. Means every number you can think of works. Every number. Every number. Like pi. I'm not going to check pi, but every number you can think of. How about 0, Jeff? Yeah, that's the easy. Let's check it. If 0, all right, see, I'll just show you. Put a 0 right here. That's gone. So then I've got -6 times 1 is -6. Okay, so, and then minus 14. Remember, x is 0. I'm checking 0. I wonder if x equals 0, question mark. 0, okay. So -10 times 2 is -20. And 0, that's gone. -20 equals -20. Hey, works. So the answer that you give typically is, well, I can't list every single number. I'll say infinitely many numbers. All real numbers is okay too. So I'll say all real numbers is one possible answer, or you'd say, or infinite. Solutions. So either all real numbers or infinite solutions is the best answer for that particular problem. It's a little weird, but they exist. They pop up. Now the other one I was looking for might be on the one I bugged out on, the earlier one over here. Let's see. Yeah, it's this one. Okay, I'm going to go back to number 9. So today I'm not doing 11, 12, or 13. Those all have, answers of some sort. Today I won't do those. Jan, maybe you want to do that today in your session.
I was thinking of covering what you can't cover. Yeah.
But I'm going to go over here to number 9 for you guys and show you what this one comes out to be, because the variables, I think, go away on this one as well. So this is 10 subtract 5x plus 8x equals 3x subtract 18, collect like terms. Subtract 3x from both sides. And you get the variables going away again. And that's false. So same idea as the other page. If the variables disappear, but it's false, then you say no solution. This indicates that you can't find a darn number that'll ever work. So the statement is no That's what you'd box for me. Don't just say it's false. I want to see the no solution. And the other one, don't say just true. I want to see infinite solutions or all real numbers. Either one's fine with me. Okay. So that gives you the overview of 2, 2, 3, and 4. And now tonight there'll be quite a bit of homework. Just that's how it felt, or excuse me, fell in terms of my planning. So tonight and tomorrow it's going to be a big day for doing a lot of these problems. But I think you'll do fine. You'll get through it. And then I think I ease up a little bit somewhere down the road. It won't be as much homework. Remember, homework's not due tomorrow. I mean, not tomorrow, but on Wednesday. Not due to be turned in. Work as much as you can on it so that you have something to ask Jan or I on Wednesday. Okay, so Jan's taking off to go into her Zoom session. Anybody need her Zoom session?
I just sent it in the chat.
Okay, and then anybody wants to stick around and ask me anything, I'll be here for the next half hour.
Hi, good morning. Can you hear me?
I can hear you,
Hi,
Sandy.
good morning. So I went and got my books. It was a little bit of a nightmare down there, but I got the wrong one.
Let's see, which one does it say?
It says it's Math 25.
Yeah, somebody else got the wrong one too in a different class.
Yeah,
So,
and
yeah.
I seen that you had yours as 150, so.
Well, that's what our class is. That's what our class is.
Yeah. So which is why I don't understand why this one came in, because it's all the books were on there when we ordered them for our classes. So
You're whack. The bookstore is whack. So here's the thing. I'm going to give you a free PDF version that'll get you by until you can get to the bookstore and tell them, hey, you guys are whack. I want my money back.
Okay. Well, I have another one coming in today, which there was 2 to order.
Yes.
From you, so I'm hoping that one will be correct, and then
the other one should be the textbook.
Yes.
Textbook. Yeah, that hopefully will be correct. So
you
either, hold on one second. Let me turn my phone off here. There we go. You can either turn that in back to the bookstore, get your money back, and just say thank you very much. I don't want to exchange this unless you want a hard copy. But I told everybody today I'm going to send a PDF out to everybody, whether they have it or not, just so you have it to go and follow me from now on.
Okay. Okay. Thank you so much. I appreciate it.
Sure.
Okay.
Okay. A number of you still here. You have some questions. I'm good to answer any questions you guys have, or you can go see Jan. Your choice. Homework questions or anything today, or personal questions, what's going on in life for you. You want to ask me personal and you want to do it on with nobody else is here. We'll just wait till others are ask their questions.
Hi, Jeff. Just a quick question on missing one of your sections. I have a VA appointment on the 9th at 9 o'clock in the morning in San Francisco. So there's no way I'm going to be able to be online. I'm just wondering if that's going to be a big problem.
So what day again, Russ?
It's Wednesday, the 9th.
So that's the day of our exam, it seems like.
Is it? Oh.
But that's okay. It's okay. Are you going to be gone all day?
No, I'll be back by probably, the appointment's probably 30, 40 minutes, and it's in San Francisco. I'll be home by noon anyway.
What about the day before?
Oh, this Tuesday, I have nothing on Tuesday.
So your exam will be released at, I think it was 8 o'clock, 9 o'clock on Tuesday.
Okay.
And so you can start it and finish it right there. And then you should be good to go to get your answers in before you take off the next day to the VA. Should be fine.
Okay. All right, thank you. The appointments are just really hard to get. I'd hate to cancel it.
No,
Okay.
don't cancel it. Thanks for letting me know, and should be fine.
Thank you.
Yeah.
Hi, Jeff.
Hi, Robin.
I just have a question about the negative and positive, which is a little confusing. When a problem says like when it says like 4x minus 2, is the 2 a negative?
Okay, I hear your question. Like that?
Yeah.
It is. So here's another way of looking at it. I can change that into this.
Okay, cool. That makes sense. Thank
Okay.
you.
You're welcome. Hi, Allie.
Hi. Um, I am like very lost on a lot of things you say, and I'm sure you're like a really good teacher, but I see what you're doing, but I have no idea like why. I really don't understand a lot of this.
Okay. So let me ask you, are you, okay, Matt's gone. So it's just you and me. Let me move this off of my little baby screen. When's the last time you took a math class?
Well, I just got out of high school, but I have like unmedicated ADHD, and I've always been really bad at math, and I'm really trying to understand this,
Yes.
but really confusing, and I don't really know what to do about that.
Okay, your last math class was last year?
No, I don't think I took a math class last year, but I had all my math requirements passed for high school,
Uh-huh.
I think.
Okay. Was it your junior year, maybe, that you took a math class?
Yeah, I think so.
And do you remember the kind of math class that you had? Was it algebra? Was it arithmetic? What's it? Remember the title of it?
No.
Okay. How did you decide to pick this class? Can I ask you that?
Counselor?
Counselor?
Yeah.
Was it an SRJC counselor or the high school counselor?
SRJC.
Okay. We have a
Just
couple.
wondering. Okay, yeah. You said.
Have a couple options. One is you're in the class and we can work through this with the help of not just me, but Jan. And hopefully it goes the way that we're hoping for, that you understand it. It's just like the first week jitters. And this is new, being in a college class, and Zoom is different. And the fires and all that other stuff that's going on. It's just really highly unusual. So maybe in the next week or two, it's feeling better and you're getting some of it. And then pretty soon you're getting more of it with the support. Here's the other option. I can reach out to the college skills department and ask, because they've got a class called they've changed the numbering, 364, 374. They got a class just before this that kind of helps with some of the pre-algebra. Things like the arithmetic, and just kind of make it a little bit more solid. And then I don't think it's too late to join that class. I can offer helping you ask the question to the instructor. So that's another option for you to consider. Hi, Russ, I'll be right with you, okay? So you have two choices I see right now, Allie. Maybe to think about it tonight
Okay,
Mm-hmm.
And
I think I'm
then,
gonna just stay in this class, but does everyone else in the class, like, are they just know what you're doing? And like 2.2, 2.4, 2.3.
well, remember that's brand new. So what I did today, you just got an hour's worth of either reminder, like if it's review. Some students are coming from high school or they had algebra last year, so it's kind of fresh. So some students it's review, and others it's been a while since they've had a math class, maybe even 10 years, and they're saying, gosh, I don't remember this. So it's new.
Hmm.
So today what I taught, I don't expect everybody to understand that until you work it out and practice it and look at the homework examples, redo my recording, listen to my recording over again and do some practice problems, and then reach out to Jan. She can do a one-on-one on some problems with you, or her study session just before class on Wednesday. And then
Oh,
maybe
I was gonna ask you about sorry to interrupt. I was gonna ask you about how do you get to her class, the extra credit? How do you get to it?
so if you go back to your emails through Canvas,
Okay.
she should have sent, and Russ, can you verify, Russ, if you got something from Jan about where to find her Zoom meetings? Turn your
In the
microphone
inbox?
on.
For
Thank
the
you.
extra credit one, it was in announcement. She puts the link right there, but that's why I came back on. I can't find her one to continue class right now.
Okay, we'll find that one for you. So, Allie, look under announcements for that right now before you leave and see if you can find it.
Okay, it's not in the inbox.
No, it's under the announcements is what Russ said. There's a little banner, click on the what's called announcements.
I was on there with her this morning. The link worked.
So that would be under your Canvas homepage, Allie, and look under announcements probably.
Okay, I see. Is that gonna be the same one, or is she gonna post like a new one every?
That should be the same one for the mornings before class every time. It should be the same one that works every time for the mornings before class.
Awesome.
Now, the one that Russ is saying, Russ, I'll give that to you again. That's a different one than the morning one, like before, but should be the same one each time. And Russ, let me take a look and see where I've got my. Okay, I've got mine. Russ, I'm going to, what's the easiest way? I think maybe the easiest way is to just show you my screen and you can write this down. That'll be the fastest.
Okay.
If you're okay with that, I'm going to try it. Can you see my screen, Russ?
It's blank.
Okay, sorry, thank you. And actually the one I wanted to show you was for Tuesday, Thursday, so that's not going to help you at all. Give me a second here. Okay, it's not there. Okay, let me get back here. Let me get into my
Jeff, I don't mean to, like I was listening to the conversation, but Allie, just so you know, I'm new to algebra too. I haven't never had it before. So, I mean, I did some college skill courses to learn a little bit, and I've been working with a tutor a lot. So a lot of this is new to me too.
That's good to know. I
Thank-
think I'm gonna try to look up like stuff and like look up like they have videos online like explaining math like even more, I think.
The math tutorial lab, the Zoom at the JC library is absolutely wonderful to get into to work with when you're having problems.
Yeah, I was thinking about going on that.
So Russ, I don't see it quickly. I'm going to send her a message
Okay.
right now on my phone.
You mean the thing she's in right now?
Yes. Do you have that extension right now, Allie?
Send it in. Didn't she send it in the chat? I can see it in the chat of this call.
There you go, Russ. Thank
I
you.
can't see, I'm showing nothing in my chat.
Oh.
Is that maybe because I left and came back?
I'm not sure. So I'm going to give you the ID number, Russ, if you just want to write it down.
Okay.
The digits.
Uh-huh.
97
Hmm.
88 12 85 741.
So read it back. 97881285741.
Correct. Try that.
Thank you.
Okay.
Good luck, Allie. I mean, I'm going to need it too, so.
Yeah, it's just, I think, I see you doing the problems, but I really don't know like why and like how everything goes together and the rules on what you're supposed to do. And I feel like,
Can I show you something else that might be a help too?
the math lab.
Because you talked about other videos. So when I go into your Canvas on the home page, and I'll show you that here. Let me get back here. Can you see this on my screen?
Yep.
Let me get back to. So I'm going to go to home page. At the bottom, towards the bottom, you see with this pair of glasses right here?
Mhm.
Okay, there's a link for a very, very good YouTube videos for all of our algebra. So when I click on that, then you'll go to one more link right here. And then you're going to see his website that has all these YouTube videos on algebra right here, along with some arithmetic basic, how to add, subtract fractions and for some review.
That's really helpful.
So I'm looking at maybe something that we did today, and solving equations probably is, okay, I'm looking here, some basic, like right here. Introducing, I see this one here. Introducing linear equations. I'm going to click on this one.
All right, in this video, I'm going to do a couple examples of solving some very basic fundamental types of linear equations. And linear equations are just certainly one of the most common types of equations you'll have to solve in any sort of algebra or pre-calculus or trig or even stats. Almost really no matter what math class you take. Equations to solve, 14 on the other side. Move terms to either side of the equation, you either just add them or subtract them. So again, I'm thinking, well, I want to get the 2x by itself. There's a minus 18 hanging out over there with him, and I don't want the minus 18 to be over there. Well, to undo that, since I'm subtracting 18, I can add 18 to both sides. And again, if you have two things that are equal, if you give both of those things 18, if you add 18 to both of them, they would still be equal. So the idea is we're left with 2x on the left, minus 18 and plus 18 is just 0, so that cancels out or goes away. We have 14 plus 18, which is 32. So now I'm at a kind of a good place. I've got, my x's on one side, my numbers on the other. And again, what I'm trying to do is I want to get x all by itself. So now I think, well, what's happening to the x? He's being multiplied by 2. Well, what undoes multiplication? Well, the operation that undoes multiplication is division. So since I'm multiplying by 2, if I divide both sides by 2, on the left side, 2 divided by 2 is just 1x. And then 32 divided by 2 is 16. And hey, now I've got my solution. So notice if you plug 16 back into the original, you get 2 times 16, which would be 32, minus 18. Hey, that would give you 14. So kind of another important thing, you can always check your solutions.
Yeah, like stuff like that makes sense. Like I get the add to the other side thing and like how things go together. It's just like 2.1 and 2.2 are like they're okay, but then when you started getting into everything else, I felt like you were just doing them and I didn't really know why. So
Okay.
that's really helpful. I'm gonna watch those.
Good. Sounds great. So I think you've got some helps. You got Jan, you got myself, like during this time as well. And you've got those videos. See how that works for you for the next 2 days. And then why don't you check in with me at the end of class on Wednesday and let me know how you're feeling.
All right. Thank you for showing me
You're welcome,
where
Allie.
those videos are. I think that's really gonna help me.
Fantastic.
Thank you. I'm gonna go to Jan's now, I think.
Yes, she still has about 20 more minutes.
Okay. Thank you so much. I really appreciate you.
You bet.
Bye.